our baseline model was a kind of sequence-to-sequence transformer. So the left part, if you see, it is a kind of conversational context vector, because if you are the NA database, and then if you want to generate a response for that, you have to capture all the previous history. Okay? So that is being done by hierarchical bidirectional industrial networks, and we capture the context vector C, we pass it to the decoder side. Okay? In the decoder side, we have two inputs. One is that generic response, the conversational context vector, and also we have used the emotional embedding to the deep emoji. We have tool. We have predicted the we get the emotional embedding. We have introduced it. So if you look into that, the right side in this particular figure, our architecture. So we have the conversational context vector. We have the generic response, and we have introduced the pointer network in such a way with the help of the reinforcement learning reward function. So what we are doing here is that in the right side, if you see in this particular part, when we try to generate a particular response, it depends on two factors. So this is the PM is generation probability. Okay, we are generating from the training. We are generating two distributions. One is that vocabulary output vocabulary distribution, and the other one is the standard sampling we are doing, this one, Y2S and Y2G. And how we are optimizing that the pointer network, we are trying to see that, decide that how much information we are generating new when we are generating response, and how much we are copying from the input. So the copying part is being tackled by this part. Okay. And the new thing that we are generating is controlled by this. So what to generate and what to copy, that we have managed using the joint reinforcement learning and joint reward between the blue is a standard metric that we use in natural language generation, and also the emotional accuracy. Okay. So these two factors we had used. So we had also used that automatic evaluation metric, like content preservation is one metric that is being used for natural language generation. The emotional accuracy, you want to find out that once you generate the courteous response, that the original emotion should not get disturbed. So it should be in commensurate with the original emotional value. Then we check the fluency by the human expert, the content adequacy, whether courtesy is properly preserved or not. And these are our scoring mechanism. So 0 means incorrect or incomplete, 1 is moderately correct, 3 is correct. Then courtesy appropriate is -1 is completely inappropriate, courtesy is not preserved, 0 is non-courteous, 1 is appropriate. So these kind of evaluations we have done. Also we have different models, simple sequence-to-sequence model, and then lot of ablation studies we have done. And these are all the results that we can, maybe if you are interested, you can go through the paper. We did, there are a lot of errors also. So because it's not the 100% accurate model, there are a lot of things we can do. So, and these are some of the error cases. For example, enhancing situation, it takes some time. Sometimes it copies something wrong. Then emotion also sometimes causes the problem. Then, for example, some extra information sometimes repeated or copied that is not desirable. Okay. Sometimes the appropriateness is not properly preserved. So these are all the factors, types of errors that we have to face, and we are still working on that to resolve those kind of errors. So to conclude, this was the very first work that we had started working on politeness. We incorporated politeness in the conversational system, and there are many interesting research directions that politeness and personalization, how these two things can be combined together. For example, politeness is very across the region. Something that is polite in US may not be polite in Japan, for example. So depending upon the geographical location, the politeness varies. Politeness varies across the gender also. When I talk to a male, I talk in one way. I talk to a female, I talk in a different way. So whether bot can behave like that similarly. Then age, for example, when I talk to an elder people, for example, I am more courteous, I am more polite. But when I talk to the junior or the younger people, I am not as courteous as those. So these are all the interesting factors or interesting research directions that can be considered in this direction. So you're working in this, or working on this domain. Okay. So maybe I can conclude now. So because time is already over. Sorry for 2 minutes delay. So thank you for your attention. If you have any question, I can go through in details. Okay. Thank you.
Any questions? Thank you, Dr. Asif. I now request Dr. Shah to present him with a token of appreciation. In the interest of time, we are skipping the key session right now, and we will have the networking and key session after the talks. Okay. So our next speaker is Dr. Rakesh M. Verma. He is currently visiting professor at Shivnagar University. He is also a professor of computer science with the University of Houston, where he is leading a research group that applies reasoning and data science to cybersecurity challenges. Today, he'll be talking on the topic of social media versus Newswire, opportunities and challenges. I now invite Dr. Rakesh for his talk.
So let's get started. All right. Today I'm going to be discussing some of the opportunities and challenges with respect to social media user-generated content versus the traditional, Newswire. And this is joint work with my students, Daniel Lee and Samane, and colleagues Om Prakash, Nawali, and Azadeh Shakri. So the opportunities I'm going to illustrate with two case studies. The first is from 2019, the Resilience Week conference. The paper is in the IEEE Explore, where what we are trying to do is investigate the timeliness and the content between Newswire and social media in the context of a disaster. And the second case study is from a 2020 paper, just appeared, Journal of Information Science, where we looked at how whether user content can help with rankings of news websites, right, and how it can help. So we'll start with the first case study. So quick outline is what is the motivation for doing it, and then we look at some of the data sets that we collected for the study, how we linked the tweets with the Newswire articles, because that's a very challenging and interesting problem. And we'll look at the results, and I'll have some closing remarks about the first case study, and then we'll look at the second case study. Okay? So, and challenges. So let's look at the motivation for the first case study. So we were looking at disaster and emergency situations, and the specific situation that we looked at is the Nepal earthquake of 2015. And what we were thinking is that, since the prevalence of all these social networks, can first responders, right, take advantage of this information, and can it help them? And actually in the morning session, we had a talk by one of the speakers on how information from Twitter can help some of the emergency agencies like FEMA, right? So already you have some understanding of that. And so here are our specific research questions. So we have 3 research questions, right? The first one is Twitter faster than Newswire? And you might think that the answer is obvious, right? But still, we want to quantify, how much information appears in Twitter and how fast does it appear. Then, of course, what type of content is present in Twitter data. And also we looked at the question of how effective are some of the techniques that have been proposed for linking the tweets with their relevant Newswire articles. Okay? So these are our research questions. So what are the data sets that we collected? So we collected a large data set of tweets using the query Nepal earthquake. And these tweets are between April 25th to June 25th, 2015. Now 99% of these tweets contain a word which is relevant to disasters. And this list we obtained from the Department of Homeland Security in the United States. Okay? And in total, we have about 336,000 tweets from 160,000 users. Okay? And let's look at the Newswire data set. So in the Newswire data set, we have 5 major sources in Nepal. And we do have, Nepali newspapers as well in our data set, but currently we are focusing on the English subset of the data set. So the English subset of the data set is from the period April to November 2015, right? And we did some filtering on the data set. We had almost 800 news articles, and there were some issues with characters in the encoding, right? So we only focused on the English subset, which is, ASCII decodable, has at least 1,000 characters and at least 10 sentences. Okay, so that brought it down to about roughly 300 to 350 some news articles. Now the question arises, can we link the tweets and the Newswire articles, right, based on their relevance? Right? So the tweets should be relevant to the Newswire article that we are looking at. And so for this purpose, we did some annotation, and we took 31 Newswire articles and 10 tweets per Newswire. The 10 tweets were selected based on similarity scoring. You may have heard of term frequency, inverse document frequency, right? That's a very popular method in information retrieval used as a baseline for most techniques, information retrieval techniques. So we used that to come up with the similar tweets. And then 10 annotators were used to label the relevance of the tweets to the Newswire articles. And they were told that they should use 3 scores, right? Relevant, partially relevant, and irrelevant. Okay, so that's how we did it. And then we took, there were 2 annotators for each pair of Newswire and tweet. And then we looked at their scores, and based on averaging and taking the ceiling, we computed a final score. And we used the support vector machine method with the radial basis function kernel and used a training data set from a different work. So this was also a tweet Newswire data set, but it wasn't relevant to a disaster. It wasn't relevant to, for example, the Nepal earthquake that we were focusing on. But we use this training data, and of course it's highly imbalanced data, right? So because most of the pairs are actually irrelevant pairs, and there is only a very small fraction of relevant pairs, right? So we did some random undersampling and also hyperparameter tuning, and you can see that the precision was roughly 47%. So it's pretty low, but still it's indicative that at least we are getting some useful results from this. And so we move ahead with the relevant tweets and their corresponding Newswire articles. And now we look at what are the research questions, the 3 research questions, right? What kind of results we get on them. And so the first question was whether Twitter is faster. Now we are only looking at those matching pairs of tweets and news articles. So the information is overlapping between the tweet and the news article. We want to see who reported it first, right? And so you can see that on the left-hand side, the tweet is slower, okay? And on the right-hand side, the tweet is faster in reporting that information. So you can see that majority of the tweets are reporting the information quicker than the corresponding Newswire article. Now what about the content of the earlier tweets? Now we are focusing on the tweets that appeared earlier than their corresponding Newswire article, and we started looking at the content. So for the content, what we did is we used a clustering method, and based on the clusters, we are going to compare them with the Newswire articles, right? So the clustering method in particular was the GSDMM method, the Gibbs sampling for Dirichlet multinomial mixture model method. And I've also listed the parameters that we used. And now, what kind of content do we have? So the way we are going to look at the content is we are going to construct word clouds of the tweet clusters and take the corresponding relevant news articles and then take the difference of the word clouds and see what is unique in the tweet cloud, what is unique in the Newswire cloud, and so on. Okay? So here are some of the clusters that we got for the earlier tweets. You can see that one of the clusters is about a baby being pulled from the rubble. Another one is a man being saved after 82 hours. On the lower left-hand side, you will see that there is a cluster about whether India is helping in the relief effort or not. And on the right side, bottom right side, you will see a cluster that talks about the clean water crisis, right? And this is one of the things that was also mentioned. So it's very interesting to see that somebody else was looking at tweets and they found that clean water is one of the issues that people have in a disaster. Okay? And now let's take a look at the difference from the Newswire, right? So we are focusing now on a subset of relevant and partially relevant, total about 172. And what we are going to do is we are going to take the vocabulary of words in the Newswire articles and the vocabulary of words in those relevant tweets, relevant and partially relevant tweets. Then we'll take the words that are unique to the Newswire articles and then look at the words that are unique to the tweets. And we can see that in the Newswire only words, right, you will see a lot of mention of government agencies and statistics about the damage, where it occurred, and so on. And if you look at the tweet only words, the unique words to the tweet, 172 tweets, you will see that it's more about the human situation, what is going on, a man trapped or a baby trapped, and so on. So you can see that these two are providing complementary information about the same disaster, right? So one is talking more about how the government is responding, and the other is talking about what is the human drama going on because of the disaster. So next we looked at how much of the information in the tweets is actually actionable, right? Because there could be information that, okay, somebody is trapped here and needs to be rescued. That's actionable information, right? Whereas another tweet would say, oh, earthquake happened with so on, so on. This is not really actionable, right? So it was, I don't know, 6.2 on the Richter scale or whatever it is, right? So we made some categories and then we looked at manually the tweets, and again we used two people to classify, right, into whether it's a report of some kind or whether it's a call to action, right, and whether it's a request, and it's none of these, okay? And we see that about 9.1% of the tweets which were matched to Newswire articles are actually actionable, right? So, we have approximately 10% of the tweets have information on which first responders can actually take some action, okay? So, with that, I will close the first case study. And it's clear that a majority of the tweets appeared before their corresponding or related Newswire articles, and almost 10% of them are actionable, okay? And the other conclusion that we draw from this study is that the Twitter content is complementary to the Newswire content. Now let's look at the second case study that I mentioned. And this appeared, as I said, in the Journal of Information Science. You can look at the details over there. What was the motivation for this study? So we have many news websites, right? And we have, imagine a generic reader is trying to decide which one to actually look at, which one to focus on. There's not enough time to look at all of them, look at all the articles on all of the websites and try to synthesize that information, right? So the reader is trying to choose or rank the websites. And we said, can user-generated content help with that, right? So first of all, what are the aspects of news websites that are relevant for ranking them? How to measure these aspects? And then finally, can user-generated content help in ranking the news websites? So we devised 3 metrics for looking at various aspects of the news websites. One was completeness. How well are events covered by, here we actually look at how well is an event covered. So this is the depth of coverage of an event, okay? And then diversity is what is the coverage across events. So let's say there are 100 events occurring at this time instant, how many of these are being covered? And then finally, the third metric is speed, which is looking at how quickly are the events being covered. The precise definitions you can see in the journal article. And here are the techniques that we used. So the first idea is to identify who are the news publishers, the accounts which publish news on Twitter. Then we extract events from those tweets. And finally, we compute those measures, the 3 metrics that I gave. We compute them based on the events that we have extracted from the tweets. So here are the results. I'm skipping over the methods because we are running short of time. So in speed, we found that